Welcome back to Math 103. This is video number 33 on growth and finance. Which version of the 15-year loan requires you to pay more in interest? The one with annual payments of $4,404.73 each, or the one with monthly payments of $360.05 each? And then why does the answer make sense conceptually? In the case of 15 annual payments of $4,404.73 each, we take the amount per payment times the number of payments and find that there are $66,070.91 in total payments. How much of that is interest? Well, the loan amount was $30,000. The principal, the amount borrowed, was $30,000. So the difference, $36,000 something, is the interest that we end up paying. How about the monthly payment version of this loan? We figured out there were 180 of these monthly payments of $360.05 each. Right, so $360.05 per month for 180 months is a total of $64,809.08 in total payments. So we see that the total amount that you pay in the monthly payment version of the loan is less than the total amount in the annual payment version of the loan. In terms of the exact amount of interest, well, the monthly version has this total amount in payments minus the $30,000 that you borrowed equals $34,809.08 in interest. So not dramatically less interest in the monthly payment version, but somewhat less. Right? So the question was phrased to ask which one costs you more in interest, and that is the one with annual payments. Now, why does that make sense? It makes sense because the first year that you are in debt in this version of the loan, that whole year, your debt is just accumulating. Right? You borrow the money, and you're not doing anything to reduce your debt during that year. The power of compounding is working against you the entirety of that year. By contrast, if you start making payments 1 month into the life of your loan, and indeed make payments every month, that means that all through that first year, you're already making something of a dent in your overall debt. So it does make sense that the power of compounding works against you a little bit more ferociously in the annual payment version than in the monthly payment version. After examining the 15-year loan with monthly payments, we can consider the same kind of follow-up questions as before about repaying the loan more quickly, but still with monthly payments. So suppose that you need to borrow $30,000 right now, and the annual interest rate is 12% compounded monthly. So same story as the previous example. If you make monthly payments beginning 1 month from now and ending 10 years from now, how much should each of your monthly payments be? And how much interest in total will you end up paying over the course of the next 10 years? So I encourage you to pause the video here and try to solve this yourself before unpausing and seeing the solution. The only thing different in this version of the problem from the immediately previous one is the total number of payments, because this is only going on for 10 years worth of monthly payments instead of 15. The amount we're borrowing is the same, the monthly interest rate is the same, and so we're just left to make this change that we plug in 120 for the number of payments. When we compute, we find that there is a smaller amount right here at this stage of the computation. Payment times something equals 30,000. So when we compute 30,000 divided by that number, we get something a little bit larger than in the previous example. We conclude that each monthly payment will be $430.41. That makes sense that this amount would be a little bit more than the 300 something that we computed based on 15 years of repayments, because we're borrowing the same $30,000, but we're paying it off faster. It makes sense that we have to make larger payments to reach our goal of paying off the 30,000 in a shorter period of time. Now, how does this version with monthly payments for 10 years compare to other versions of our loan? Well, in this version, you're making $430.41 payments per month for 120 months. 10 years worth is 120 months, and that's $51,649.54. Of that total amount that you're paying back, well, 30,000 of that was just paying back the original amount that you borrowed. The difference, that $20,649.54, that's the interest. That's how much money the bank will make in profit from this loan. How does that compare to our other loans? Well, it's a little bit less painful than the interest you would have paid, 23,000 something, if you made 10 years of annual payments, right? So this is 10 years with monthly payments, 21 something thousand, 10 years of annual payments, 23 something thousand in interest. Okay, it's a difference, that's real money. But this loan with monthly payments for only 10 years instead of 15 years, that's a really big difference. The difference between 10 years and 15 years is a difference between 21,000 something in interest and 34,000 something in interest. That's quite a substantial difference, so try to be in debt for shorter periods of time rather than longer ones. And that is the end of this chapter. Congratulations!